Welcome to today's session. This is a career reset, surviving and thriving in the AI economy. I am Edward Momeka. I'm the founder and chief architect of a consulting company called ThinkMind. We're a cloud and AI partner of Microsoft, and we're essentially in the business of AI at this point. So the TLDR of this session, what we're going to talk about is if there is nothing uh, if there's no value to your knowledge, abandon your knowledge. And really, the question that we want to ask is there still a need for making things, right? As a technologist, as a software engineer, what is the need there, right? Who am I and why should you listen to me? Well, I have about 30 plus years of experience as an enterprise architect. I'm a Microsoft MVP for AI. I'm the creator of the Calabash Agent Server, which is an AI agent platform that allows you to build technology on top of AI to do things for your enterprise line of business applications. I have a YouTube channel, or we think mine has a YouTube channel with over 200,000 subscribers. The link is there, and I'm on LinkedIn. And if you want to connect after this session, you can use the QR code there to connect. Um, so what are we going to be talking about today? So before we get started, just a quick reality check, right? So everything tonight that we're going to be talking about is real code, real agents, real shipping products, no lab demo stuff. My portfolio, things that I've built in the past. Basically, I built flexpay.com, which is a digital business banking platform. Calabash, obviously, our product. You can get it at trycalabash.com. I built a platform called BibleWise, which is really the first content-driven AI platform ever. It came out back in 2019, and it takes various 12 different Bibles, consolidates it using a lot of the practices that we talk about on this channel to create a comprehensive reading experience that allows people to get to the root of things. And then, as mentioned, we have Calabash Publications. I'm also an author. I wrote Professional C Sharp back in 2001. It was a global bestseller. It's the launch of C Sharp programming language, the first book on C Sharp programming language. I started writing it in 1999, actually 1998. I also wrote real world Windows 10 development and C Sharp for Java development. And I'm currently working on another book called Enterprise AI. So, who should stay for this conversation? Well, developers of all levels. So if you're a coder, then it's good to, we're going to be talking about AI and its impact in the real world. So it's good to know. If you're an AI curious engineer, this is also a good place to be. If you're an architect and you're building governance, you're in technology leadership, then it's definitely the more knowledge you have about AI, the better it is. And if you're any kind of technology leader, um, this is a great place to also be. Now, one thing about myself, beyond having my company and doing all this stuff, our consultancy, we deal with C-suite executives. So we're constantly having discussions about AI, how AI can be used. In fact, there are various projects that I'm the chief architect or enterprise architect for overseeing overseeing it. And the biggest question in everybody's tongue, once we get past the technology that or the domain that they're actually in, is how does AI actually impact what they're doing, and what are some of the changes that they need to do in order to be able to adopt it. Okay, so let's get to part one. And part one is the bearings, right? So before we get going, there's really two things that we want to talk about when we're discussing AI. We want to talk about internally controlled and externally controlled modes of operation. And so the externally controlled you've seen before, right? That's a Microsoft Foundry. That's the stuff from 11 Labs. That's Olama, not the desktop version, the cloud version of Olama. That's all stuff that's being handled, the models and the agents that running. outside of your enterprise. Then there's internally controlled. So here's where you have full control of the scope of what's going on. And typically there are three, four layers that they can fall into. You could have something that's low sovereignty. So in a low sovereignty scenario, you're still leveraging external agents. You just have the interface to the agent located inside of your enterprise. So something like when you use GitHub Copilot, you're using GitHub inside of your environment, but the agents themselves are hosted outside of your enterprise. Then there's the medium sovereignty. This is where you have an app service that has an LLM that it's working off of. So the agent itself is being hosted inside of your environment. And we're going to show demos of this, but inside of your environment. And the LLM itself is what's sitting outside of your environment. So, for example, this is a scenario where you might be leveraging ChatGPT. You have an application that makes calls out to ChatGPT, but all the business rules around how the results are compiled, all the places where the data is coming from and being pulled from, is actually inside of your enterprise, right? Then you have the high sovereignty scenarios where you're running inside of a cloud container or you have a VM with a local model running in it. And in this scenario, the model itself, the LLM itself, is actually sitting inside of your enterprise as well. So you have full total control of everything that's going on. But again, the whole entire environment that you've set up, even though you have total control of it in terms of the fact that the LLM, the containers, the VMs, everything is running within your environment. That environment in and of itself is still sitting on the cloud. So you still, it's really not, even though you own it, you control it, you have a lot of controls associated with it. You're still susceptible to things like outages that might happen on the cloud side, and security breaches that happen on the cloud side. Those still affect you. And then finally, you have the total sovereignty where basically the whole entire thing is running on-prem in your environment. And these days, we're seeing laptops now where your LLM is actually running locally. Everything is local. You can use it even if you're not online. Olama offers this capability. You can install it and run it all locally and not be connected to any cloud framework. But of course, the shortcoming of these approaches is that you basically lose two things. First of all, you lose all the vast number of tools that are working with each other that are all cooperating to create the result that you see. You just have the LLM, so you just have the static database without any tools associated with it. You have to build your own tools, and then of course, it's not distributed, right? You're basically working in a silent environment unless you create that distributed architecture yourself. So let's talk about how we got here, okay? And the story of how we got here is really going to tie itself well to agents when we start getting into it and workflow and things of that nature. But we're really going from a world of manual chaos, right? Enterprises are based on capabilities and functions and business services that are driven by people, process, and structure to create all this stuff, technology, right? And the biggest problem in the whole entire setup is the people part, right? But the people part, we're the glue that sort of shifts things along in workflows, in orchestrations, in processes. We're the ones that you call, or even if you send an email to a person to start the actual workflow. So we're active participants, or you could say active nodes inside of a workflow. And that manual chaos can be extremely difficult to untangle. And we've been trying to untangle this thing for many, many years using many, many different techniques. There's many processes that are in place to help solve all kinds of um, problems associated with human workflows. PMP is a human workflow solution. TOGAF is a human workflow solution. All the ITIL stuff is all human workflow. Six Sigma is all human workflow. It's all about how to organize people so they act in a predictable manner, and how to rationalize the entire experience within an enterprise of all the people working together to get things done, right? And ultimately, what you want is that as things pass through this cube, right, they become more stable, more organized, and what you end up with on the other side is basically automated order, right? We know how things are flowing. And that's the first step and the first evolution of AI. The first thing that AI did was say, or the first sort of thought process around AI is first of all to say, how do we take this manual chaos and how do we create automated order out of it? How do we make some of the patterns that are predictable that humans are using? How do we take that and just have some kind of automated system make that decision in lieu of a person making that decision and move the process forward? Because once you introduce computational capabilities, you remove all the drift associated with the outcomes of interactions with a business, right? So as part of this, we then move on to the idea of the workflow, which is kind of like what I've been giving away all this while, right? And orchestration. And workflow and orchestration is a way, as stated, to remove that manual step, that manual flow from the experience of working with individuals, right? So when you're interacting with an organization, when you're interacting with a business service or business capability, you basically can leverage a workflow to try to get some things accomplished for you, right? That way you don't necessarily have to deal with the drift that's associated with the outcomes when you're dealing with individuals, right? But with that said, we there were still things that we're not able to do, right? So we took our organizations and we took our technology and we put it onto the cloud, and we automated everything using SaaS platforms that do automation, using ITIL and BIPL platforms out there, and all the different ways, setting up workflows, building services and service-oriented architecture. But there's still a missing link around the actual intelligence part of it. The problem with the workflows is that it's too deterministic and too rigid and too predictable and operates in the same way every single time, and is not very fault tolerant or tolerant to unique experiences. So what happens is that even though you have these orchestrations that are built out there and they function properly, you typically in edge cases, you end up having to fall out into a person anyways, right? And it turns out that for the most part, you're really talking about a 60-40, a 70-30, and sometimes 50-50 breakdown of how many people flow easily and smoothly through the workflow versus people who have very unique experiences, very, very unique situations, and they actually need to speak to a person one way or the other. So that missing link is solved by applying intelligence to your enterprise. And what I'm going to start out with is I'm going to start out by demonstrating to you an unintelligent enterprise and how an unintelligent enterprise might function. So, in an unintelligent enterprise, for example, you would have a web application that's here, and this web application is sitting as an example inside of Azure. And the web application basically connects to various databases to get information about about what it needs in order for it to accomplish its capability. The database also may or may not interact with underlying systems that might exist inside of your network and other databases that might exist inside of your network. So what lives over here is what's directly inside of your infrastructure. So you have complete custody of this environment, and what lives here is what is running on your cloud platform, wherever that's located. And the first step, and we talked about this a little bit, is our move towards low sovereignty. Okay. And in a low sovereignty environment, right, you basically still have your your application running inside of your enterprise, but you've now taken all the brains of your application and you've basically mapped them somewhere else, right? So these are all the brains. These are the things that know things. And then over here, also mapped somewhere else, is an agent that you have running on the cloud, right? So the only thing you have running inside of your environment is an agent description, right? Something that tells you where the agent is located and the user interface that's going to actually interact with the agent itself. You don't have anything else running inside the environment, right? And then if we move on to the next transitional architecture, the next way that you can view the system, we now have something like we talked about that is medium sovereignty, right? So in this environment now, you have here inside of your environment, you still have an agent description, but that agent description applies uh, to this entire section as your agent. This entire section has a database that's associated with it, and it has an LLM that sits somewhere on the cloud. So this right here is a cloud-based LLM. This also has access to something called MCPs that we'll talk about in a second, stands for Model Context Protocols, which can be used to provide additional context for your agent that you have running. So in this kind of scenario, you have some sovereignty, you have some, no pun intended, agency, but still you're really dependent on a lot of things sitting outside of your environment. Obviously, if any of these chain links are broken, then you lose the context and the intelligence associated with them. And if this link is broken, then you completely lose the brains of the operation and you become an unintelligent platform as well. That's why there should be a measure when you build systems like this of failover by having a database located here that you can use to basically answer some questions that might not be available to you. So the next one that we'll show is basically the high sovereignty environment. As you can imagine, this the high sovereignty environment and the total sovereignty are essentially the same thing. They basically represent having full control of your environment. In the case of high sovereignty, that full control of your environment is still sitting on the cloud. So technically, you don't have total control of it. You have a lot of control, maybe 99% control. But technically, if you somehow that connection to your environment was severed, then you would lose the access to that. You would lose access to that environment, which is not a good thing, right? Let's talk a little bit about, now that we understand kind of like the general gist of it. Let's talk a little bit about the kinds of enterprise workflows. As we discussed before, we have these workflows that are sitting inside of our environment, and these workflows have now kind of evolved from humans doing the work themselves. And if you've worked in an organization, you would be very familiar with HR onboarding. You'd be very familiar with case management and support. So you need to have access to some computer. You either send an email somewhere or you go on some software platform somewhere and provide some of your information and make a request. A ticket gets created. Someone works on that ticket to enable that access for you. by going into the identity and access management platform for your enterprise. Once that's set up for you, you get some email. They'll update the ticket to say, hey, this ticket is complete, and then you get an email back. So, what that ticketing system is in a traditional sense, even though you're inside of the workflow, what that ticketing system is just a way to record what needs to happen. It's not really doing any of the orchestration. The orchestration is implicitly happening amongst the participants, right? If that ticketing system wasn't there, you could just contact the person who needs to do that work, and then they would do the work for you, and then you'd be done. And in a lot of cases, in a lot of enterprises, the ticketing systems themselves, the reason why you're directed to the ticketing system has a lot to do with just accountability and not necessarily uh, organizing work, or maybe accountability, organizing work, things of that nature, but not necessarily like getting things done, right? It doesn't assist you in the workflow. It just helps people organize what needs to be done and helps you have a record of what is being done in association with your HR onboarding, right? And this is the same thing with approvals and financing, and the same thing with content and document management. These things all follow enterprise workflows that basically dictate how they how they all work together. And they really do have, most importantly, four key things um, uh, that drive their behavior. One of them is that they're very human centric, as described. They're extremely dependent on people actually making judgment calls, doing all the decisions, and doing all the actions. Um, there is some automation enabled, right? But that automation is just, for the most part, routing logic, right? So when you say that you want to get a new laptop, and you provide your cost center or who your manager is or something like that, the department that you're in, it might route the ticket to an individual that is inside of that department versus just generically going to a pool of people that handle that situation, right? And that routing might still go to that pool, and the routing is around where the funds come from. So maybe it still goes to a pool of people working on it, but now that all gets routed to your finance system, and your finance system basically says, we're going to build this cost center for me versus another cost center for you, right? Another characteristic of workflows is that they usually typically have a visual mapping associated with them, right? So we've all seen the giant workflows with all the steps, with the if ors, if this, if that, with the swim lanes that show the different areas that they go up or down into, left or right into, um, pretty standard. Also, state transition diagrams are great diagrams to depict these flows as well. And then most importantly, workflows are extremely metric driven, right? And that is that typically the reason why we're using these systems, for example, I gave ServiceNow as an example. Another reason why they're used is to track the work that's being done and to track how long it takes to do the work. And in various scenarios, based on metrics and KPIs that have been put in place, to be able to say, okay, this took too long. Why did it take too long? And do some kind of remediation and refinement to improve the process, and maybe apply more workflow to it, faster approvals or remove approvals, or streamline the process as a whole. There are many outcomes that can come out of properly applying metrics to workflows. Ultimately, where we want to get to, right, and where the workflows wanted to get to, is this idea of a continuous orchestration engine, right? And the idea of this continuous orchestration engine is that you do mapping of the workflow and all the edge cases, that you customize it, that you connect it, and that you automate it, and then you refine that process over and over and over and over again to get it better and better. And that step, that process is precisely the kind of thing that AI um, works great with, right? That idea of iterative refinement is built into AI and AI models and your agents, as you know. The idea of the mapping, the customizing, the connecting to different data sources and integrating with all these sources, and the overall automation is a critical component of AI. And we'll talk a little bit in a second, or we'll talk a little bit about this, as we move on. So, with that said, one important thing to note is that this shift that I've described, this shift from this underlying workflows that have driven organizations for time immemorial, or really has been going on forever. So if you think about it, a typical knowledge worker today basically is reading and summarizing emails. They are preparing reports. They are updating systems and scheduling meetings, and they are researching vendors and writing proposals, right? So, and you can mix in whatever mundane, office activity or enterprise activity that might be in here. And generally, it involves a human being interacting with a computer to tell the computer or to direct the computer in some way to do things. And the skill is not necessarily even the skill of understanding the business domain, although that is very critical. It's really the skill of being able to translate your understanding of the business domain into the digital computing formats, right? So AI agents can now perform these tasks end to end. Again, going back to the old days, when we had meetings, we used to have people that were scribes. We used to hire young college students, interns and things like that, and they would start out as what they call a project tech, and they would sit in meetings and they would take notes, and they would compile the notes into documents, and they would send the notes out at the end of meetings. That was one of the tasks that they would do. Well, I mean, I think everybody has been in a Teams meeting and seen the transcriptions and the summaries and all that stuff in there, right? That's basically built in now, right? So the bottom line is we are moving um, from basically this idea of software tools, right? Which is where we're at right now. We're in this transition. So the work days, the Azure DevOps, those kind of things, a tool that you configure and use yourself. We're moving from that world to this world of a digital coworker, right? So the interaction is less like you clicking on buttons and drop downs and selecting different things and letting it go out and do it. The interaction is more like you having a personal assistant, and asking your personal assistant to get things done for you. You still have that knowledge yourself, but the way you interact with the computer now is now less. There's less of a skill, or there's less value in the skill of being able to translate your your knowledge, your domain knowledge into terms that a computer can understand, because you can now just speak to the computer in plain English to try to get these things done. Right. So we now understand the shift has started. These agents exist. They can do tasks, and we're moving to a world where they're going to be your coworkers. So let's now ask the question: what is even an agent? What ultimately is it, right? So when we're talking about AI agents, it's not just we're not talking about just chatbots that answer questions, right? And everybody, if you're using AI today at your workplace, if your enterprise is allowing you to use AI, then they're basically allowing you to use a chatbot. You're probably on, if you're in the Microsoft ecosystem, they probably got Copilot running for you. And so you've got some private instance of Copilot, or maybe some private instance of ChatGPT. that's in dedicated hardware that's separated from everybody else, and that's what you're running on. And because they don't have a lot of, because we're the world, it's still wide open and we're in the Wild West. um, they're probably not letting people do any actual development leveraging the AI. That you're probably in a world where AI is being used as a tool to help enhance your knowledge, right? So you're able to ask your co-pilot questions about what's going on in your enterprise, right? So if you want to know who's doing this or what this term means, or maybe ask questions about, hey, if what happens if a customer gets onboarded into our platform? What are the actual systems that get touched? Your AI has scanned your entire enterprise portfolio, scanned all the emails, all the meeting notes, all the text messages, everything. Your AI has done all that. And so when you ask this question, it's going to answer it, similar to ChatGPT, but now tailored to your enterprise. So that's basically how AI is really being used right now in the enterprise for the most part, right? Especially for large organizations, banks, like the state, things like that, right? So the distinction between these chatbot systems that you're being exposed to today and that you're leveraging today and an agent is that an agent is a system that pursues a goal, right? So you're not you're when you're asking your agent, hey, what happens with the sale process, the customer onboarding process when they make a sale? What systems does it hit? What does it connect to? Does it Is it stored in this database? Are there endpoints associated with it? You're asking these questions that are tailored to trying to understand how let's say your e-commerce platform functions so that you can do certain things with it. Well, the real question you have to ask is, what are the things that you want to do with it? Well, let's give an example. You need to write up some kind of software architecture document that describes your systems, or you need to create some kind of proposal for some new capability that you want to add to it, and you need to understand where the connection points are to the old system and how it's all going to work, right? So in the chatbot model, you're kind of still that person, that man in the middle, and humans are still the man in the middle that are basically making the decision on what to ask, what not to ask, and compiling the final work product and presenting the work product to the rest of the world or to the enterprise, right? So not much has changed in the chatbot world. It's just that instead of you, again, needing to know where the drop downs are and which screen does this and which button does what and what order you need to like do this and that and how to back out of an order and how to, instead of needing to know the mundane things associated with the Chrome of an application, you can just ask the application and it'll provide that information to you in collated and well set up so that's easy for you to consume. So so we're still in that world, right? Even though we're using chatbots, just a better tool to solve the same problem. But when we now talk about agents, what we talk about is you now saying something like, hey, create a design complete with the documentation for this new capability that I'm thinking about that needs to do this, this, and this, right? So you think about yourself conceptually as a manager, a CIO, a leader, and you're talking to a subordinate and you're asking the subordinate to take care of things. When your CIO or your CEO or your manager asks you to do something, they don't they're not sitting there with you telling you how exactly to do it, right? And if they did, they'd be probably a terrible manager. You probably wouldn't want to work for them, right? They just give you the directive of what they want accomplished and you're focused on the outcomes, right? All they care about is the results, that did you produce the result in the way that they wanted it based on what they ask you. They don't need to know, they don't need you to be procedural about how exactly it's done. How it gets done is within reason, is not really relevant to what's being discussed. So this same thing applies here. The agent itself decides, the agent itself acts, the agent itself observes results, and the agent itself improves its own behavior. That was from the cycle that we showed 2 slides ago, right? And so its goal, you inject a goal, then it plans, it acts, it observes, it improves, and it repeats the process, just like what we showed here. The same kind of thing happening. That's essentially what an AI agent is doing behind the scenes. So that's conceptually what it is, right? And we kind of understand it's doing all this magic and it's doing all this stuff, but it's still, the question still remains. But what is like what really is an agent? What really is it? What's really happening? Well, at the root of it, at the very root of it, um, an AI agent is nothing more than a workflow plus a reasoning model, right? That's the reason why, as we talked through this, we went through a process of understanding workflows and understanding the rationale behind workflows and understanding how workflows have metrics associated with them and how the metrics associated with the workflows can be used to streamline and optimize the workflow by going through it and passing through it over and over again. It becomes better and better and better. And typically a workflow is measured by looking at its outputs and using its outputs to determine the efficiency of the workflow, the accuracy of the workflow, and then those outputs are used to refine the workflow so that the next time that data is passed through it or request is passed through it, it's more optimal. So underlying that underlying concept is essentially what's an agent is. On one hand, you have the workflow, which handles the static parts of an interaction, right? The parts that have always been there, right? So in the normal orchestrations and processes and workflows in an organization, these are the parts where decisions are being made outside of you anyways, right? So in the example that I gave of a ServiceNow ticket, you put in your cost center code, and your cost center code automatically routed you to a resource that was associated with that department and automatically routed the payment for that laptop you're looking for to your cost center so that your cost center is billed for the request that you made, right? And if someone else came in and did it, that was the different cost center, they may get a different person and obviously will be billed to their cost center. So that whole flow is one aspect of it. Then the other aspect of it is the triggering, right? So how do workflows start? What makes a workflow go, right? So one big trigger for workflows within the enterprise is emails. Another is Teams. Another is an enterprise event. And a really big one is just time. And we see all these within our workforce today. We see it in time. So any batch process, it runs every single night. Your banking systems, every night at 2 a.m. something is triggered. Your retail systems for some kind of retail store, all the orders at the end of the night when the store is closed, all the orders at some point during the night before the next morning and the stores reopened, every single thing is pushed up to the central location where it's collated and reported on, grouped, reported on. And that's how at an enterprise level, a store like a McDonald's, for example, can see, oh, here's how we did last night across this region, in this state, in that state, in for this demographic, for this income status. When you start combining it all together, that's all happening by time triggers. Enterprise event triggers, what are those? Well, we just give an example. A person is hired, right? An order has come through. Those are all enterprise events. A person is let go. Each one of those things would trigger a workflow which has humans that are sitting in there to help push that workflow along. Email and Teams, right? So you send an email to someone, and that email you send to them might be an email that you need to send to start the process. A lot of times, support tickets actually start with email. They don't start with a system like ServiceNow. They actually start by them saying, "Hey, send the support to if you have some things, send it to this email address, and then it'll get picked up from there, and someone will create the ticket or contact you or what have you." That's the flow that it follows. Right. So the workflow provides you with triggering, it provides you with flow. And by flow, what we mean is the branching, the information capture, the deterministic processing, and the action, right? The action, the doing of things, right? Making things happen. The when by action, what do we mean? We mean state change. So some enterprise state has changed, right? Based on this workflow. You didn't have a laptop at the beginning of it. You made the request for a laptop, and at the end of it, that request for a laptop has been stored in a database somewhere, and an email has been sent out to somebody somewhere else, to maybe to CDW to to provide a new laptop, or a service call has been made to CDW's API, and they are now shipping that laptop to your address, right? Something happened. The world changed based on the workflow. Then the reasoning part of it, this is the brains of the operation, right? So the reasoning part of it is where we used to sit, right? So we used to be the reasoning part of it, right? And in the example that I gave, when you send that email to the support ticket people, someone had to read that email and someone had to say, "Hey, oh, this person wants a new laptop, or this person has a problem with their this, or this person is that," and then this individual was the one who would create the support ticket, and this individual was the one who would say, "Oh, this guy is emailing me from here. Let me look up who his manager is on Teams. Oh, his manager is this. Oh, he's in this call center. Okay, I'm gonna put that in. Oh, I think I know he's saying this, but I think what he really wants is this because I've seen this so many different times. So I'm gonna just go ahead and put in exactly what he wants, clarify the language so that my tech guys, the people who are actually going to do the work, know what they're talking about, and I'm going to submit this snow ticket, right? So that was a person's job, right, to do the reasoning within the workflow. So what is the AI doing? The AI is replacing that individual, that capability. And what the reasoning model does is it takes your email, and it captures all the necessary information associated with your email. And then it actually submits an order into the ServiceNow system on behalf of you based on the information that is summarized. And if there's information that it did not understand, or information that it's not clear on, or information that is missing, it will send an email back out to you and tell you, "Hey, I understand you want this, this, and this. Do you mean this? And can you also provide these other pieces of information so that I can fulfill the order?" So it's going to take over that whole role within the workflow, and basically be the one that drives the workflow forward, right? So that's pretty much what we mean when we say an agent. We mean a combination of an underlying workflow, and that workflow is still going to exist, right? Because that workflow is integral to the way organizations operate, because ultimately organizations do require a measure of determinism, right? Every time a person places an order, right, you want for the product to show up at their place if all the right characteristics are met. And this goes across the board. Every organization wants to be able to replicate all their capabilities 100% properly every single time. That's how you reduce costs. That's how you increase your efficiency. That's how you make money. So we're not going to go to a world where you're you don't want to be in a world where you're thinking, quote unquote, about everything. And yeah, as I always say, we're not so different from from these AI agents, right? Because we don't think about everything. We don't think about our heart beating. We don't think about necessarily breathing. We can in the breathing sense, but we don't think about it. Because if we thought about it all the time, then we wouldn't be able to do all the other things that we need to be doing and wouldn't be able to think about all the other things that we need to think about. So it's the same process of pushing things down to a nastic system for reacting to things as opposed to a rational system for reacting to things. And if you take the human brain and the human setup and compare it here, you could say that the workflow is like our central nervous system. And obviously, the reasoning model is like our brain. The events would be like the stimuli that we respond to, like, and the difference between a workflow and how a workflow reacts and the reasoning and how reasoning react would be the difference between when you step on a hot surface versus when you see a beautiful landscape, right? So when you step on a hot surface, it doesn't ever get to your brain, right? You're reacting instantaneously because it's already it's a deterministic response, right? That's what's going to happen every single time, right? Unless you literally force yourself not to do that. But that's how you're built out versus how you react to a sunset may be different based on your mood, based on the kind of sunset, based on the colors, based on all kinds of things, where you're located, how warm or hot it is. All those things can affect it. Okay. So I think we beat that to death. So let's talk a little bit about chatbots versus agents, right? So, and we kind of already discussed this, right? So, a chatbot responds to prompts, pretty much straightforward. Agents perform tasks. And we talked about this. Chatbots have passive conversation, and agents are goal-driven execution, right? So when we talk about an agent, we're talking about state change, we're talking about things happening. And remember that what is driving those things happening is typically a deterministic workflow that's sitting underneath it. Just like your brain doesn't actually do anything, right? All your brain, in terms of like in the real world, right? All your brain really does is pass messages through the workflow of your body, which is again the central nervous system, to actually make things happen. Everything is actually executed through a workflow, right? Not directly from the brain, unless you're, Jean Grey or something like that. So let's now move over to an example of how agents work. And we've kind of gone through this before. So we want to prepare an estimate. And what it's going to do is going to search all the internal documents, collect market data, analyze work done, find the workers to determine hours, and send the quote out to the users. Each one of these steps after the goal of preparing an estimate. Right now in your enterprise, if you don't have a true agentic enterprise, you are still doing yourself and you're essentially just leveraging AI to like help you, right? So you're calling Chat GPT and Chat GPT is doing this search for you. Then you're taking the search responses and you're, collating it yourself, right? And then maybe you're asking ChatGPT a whole bunch of questions about market data. And then ChatGPT or Copilot is returning that stuff, right? Then you are the one that's maybe analyzing the work to be done, or you're adding all that stuff into ChatGPT and you're saying, hey, analyze this and give me some result. And then ChatGPT or Copilot is doing that, right? And then more than likely, you're going to be the one that's going to get some report of workers that have done work and hours that they've worked, like contacting whatever or looking at the your payroll system or what have you. You pull that information together, And then you are the one that's compiling this overarching document and sending the quote out to your users, right? So you're the participant, that's driving this, right? This, and then finally this. You're the one that's moving everything forward. You're the reasoning model, right? In this case. And what we're saying is that when you're using an agent becomes that reasoning model. You're not needed in that space. You're needed here, okay? And you're needed in the end here to basically review the outcomes, the outputs of what the AI has created, right? And this is one of the most important things. Well, let me not say that. This is an important thing to note as part of this discussion and moving forward is that we're vastly, we're very quickly moving towards an outcome based mode of operating with computers, right? With technology, as opposed to this task based way where you are the actual, you drive the outcome, you create the outcomes. We're now just being able to refine these flows, being able to inspect outcomes, and then re-ask questions and refine the workflows and refine the understanding of the agents such that it can create the outcomes you're looking for, and create it in a predictive, deterministic manner is a principal skill in this new age. And we're going to talk about skills a little bit later, but just pointing that out. So, what is the impact on workers? In the old model, workers produce the output, as we discussed, right? So, workers are the ones who are actually doing the output. In the new model, workers supervise systems, right? So, you're no longer the guy doing the work. You're now like a manager of some sort, right? And we've seen this work before, even if it's only in fiction. If you've ever if you're a Star Trek fan or ever watched Star Trek, that's kind of like the model. That's the model that was envisioned, right? It's a model where there's a computer, there's an AI, it runs a ship, it does everything. And it's really about your way to communicate with the AI to get the AI to do things with some guardrails in place. That's how you interacted. It wasn't about you going in there and typing in the keyboard or all kinds of stuff like that. You just kind of knew, and you just kind of spoke to it and reasoned about it. Think of yourself more as a philosopher, than as a technologist, right? Right. Now, the new core skill is task specification, right? So that's a critical thing. So it's about how well you can describe your prompts. Your prompts are the new programming language, right? Your prompts are like the things that actually make things happen now. You don't need to go in and sort of like make it happen yourself or write your C++ plus plus or your C sharp or your Java. If you develop a well-defined prompt, it will work for you multiple times to be able to handle multiple scenarios. And you should think about these prompts as programs or like tools in your tool belt. The more prompts you have, the more prompts you've refined, the more effective you are as a worker in the new world. And then sadly, entry level information transfer roles are definitely on the decline. So what is an information transfer role? First of all, so break it apart because there's two things in there. The first part is entry level, but the more important part is the actual role itself, which is information transfer role. So we've been talking about an examples of in our session of you or an individual going into a service now and entering information based on what a request that a person has, or going into Azure DevOps, or going into your finance system, or putting in your timesheets, or putting in your expense sheets and whatnot. All those are all information transfer. That's all information transfer. It's taking things that's in your head or that's on paper in one form or another and putting it into a computer. Now, in the entire history of computing up until when this technology started to emerge, there was what's called an impedance mismatch between our understanding the real world and the digital world. And much of what has happened since the beginning of computing has been more and more efforts of us helping to sort of like blend that distinction and that barrier that exists between them, right? So when computing started, it was ones and zeros, and you were flipping ones and zeros. You had machine language, right? Even machine language itself is to a certain extent an abstraction of what is of the actual underlying physical architecture. But let's take machine language as the lowest level, right? So a machine understands ones and zeros, and that's how it operates, right? And then these first level languages came about that said, well, instead of me putting 10010011111 when I want to when I want to store the number 53 in an integer, right? In a number, I want to basically say, hey, this is number 53, and then maybe doing another 10000 whatever, and that's supposed to be add 10 to it to get 63, and then you get the result back in this computer registry somewhere that's another bunch of jumbled up numbers, and then that actually means 63. Instead of me having to sit there and do the actual binary mathematics to convert all this stuff and understand what's going on, let me just create codes that represent those numbers. Let me just take them and have like some kind of nomenclature, some kind of mnemonic that's associated with each one of these different codes that's out there. And so was born sort of like this idea of assembler language, where now you're no longer saying 100, you're now saying add, and then you put this, and then you're saying push, and then you put this, and you're saying pop, and then you do this, right? And then that's how the computer understood it, right? And the computer was interacting with us from the perspective of we push things into a stack, like putting things, like in a cafeteria, how you have the plates and you stack them on top of each other. The first plate on the stack, as more plates get added, it gets pushed further down, and as you remove plates, it comes up. That's when you're giving the computer instructions, you're pushing all the instructions down like that, and when it's reading the instructions, it's reading them out in reverse just like that, right? So that's what's happening at the physical layer of the computer, right? And then someone came about and said, well, let's make it even more abstract than that, right? No one needs to know that you're pushing things into a stack and pulling them out of a stack and all these things. Let's just do this stuff for you, and then let's give symbolic names to them. So that came about the idea of having functions, right? Having subroutines, having labels. Instead of you saying add whatever, now you can say age equals 10, right? Something that would be easy for you as a computer scientist or a general person to kind of understand what they're talking about, because most people would have arithmetic knowledge, right? So age equals 10, salary equals 10,000, age plus salary equals 10,010, right? Basic concepts that anyone would understand. And then you had these things called compilers that would take the basic language that a person might understand and convert it back into that machine language such that the machine could process it. So this problem that I just described has existed since computing started. There's been a language barrier between us as humans and the computer. And there's been various compilers have gotten better and more sophisticated. New languages have come about that seem more like a person speaking to another person. But regardless of whatever happens, there's always been that problem of that you have to take what the person is saying and convert it into what the computer understands, and actually for it to actually do things. And it's never been what's called full of context. It's always been context free, right? Meaning that If I say add one to two, I literally mean add one to two, right? If I say something is cool, I mean it's cold. I don't mean that it's nice, right? If I say something is hot, I mean that its temperature is high. I don't mean that it's, I don't know, attractive or like it's selling very well, or a lot of people are paying attention to it, and all the other ways that context changes the meaning of words. In the age of AI, that barrier has seemingly gone away. Now, a lot of things are still happening behind the scenes, but from our perspective, it's gone away. So, all the languages that we've been used to interacting with a computer with, C++, C Sharp, Java, TypeScript, Python, even languages that don't seem like languages, drop down menus, buttons, like lists, data grids, those are still languages, text boxes, right? It's a way for you to communicate with a computer. So it's a language. It's a visual language, a visual representation, or Chrome. All those things have now melted away, and you can now finally talk to your computer like you would talk to another person, right? And by virtue of that, circling it back to this last item, information transfer has become commoditized, right? Because a lot of what the work was, a lot of what the skill in your in our jobs was in knowing how to use the various languages to communicate with the computer. We were translators. Our job was being a translator. So imagine you're a translator for the UN, and one day an app is invented that you can just put earbuds in your ear, like what Apple is trying to do, and it will automatically translate in real time anything anyone is saying perfectly every single time, right? Well, how valuable would your skill be then, right? That's where the information transfer becomes a problem, and then and then there are still high order information transfer kind of roles, but then the second part of it, the entry level part of it, now becomes a problem because that's now saying, hey, I don't even know how to do information transfer, right? You've got to train me how to do the information transfer, and then I'll do the information transfer. And I'm using that word train deliberately. So now an organization might say, well, if I have to spend X amount of dollars training you on how to do information transfer, I might as well train an AI to be able to do information transfer, right? So instead of me teaching you how that, hey, yeah, I'm going to have to take the receipt, scan the PDF, read all the values from the receipt, and input them into our expense system, and then submit it so that someone can send you a order. I can just have one of my developers build a Power Automate flow that uses image processing AI to read the contents of the receipt and do all that work, and then trigger the workflow and do all that work without having to hire you, and I don't have to deal with insurance and all the other things associated with you as an employee, right? So that's potentially that's potentially something that can be an issue. Okay, so now I want you to understand, because I get this a lot. Okay, I get this a lot. Like, you'll start talking about these problems, and then you'll get the, oh, it's never gonna do this, or oh, it's too expensive, or oh, whatever, right? But what you have to understand is that the train has left the building. And one of my favorite movies, The Matrix, says it best, right? Which is, there are levels of survival we are prepared to accept. And this is the way the enterprise is thinking, right? there are levels of survival we are able to accept. So there's a word for it now, and we see it every single day. Software gets worse and worse and worse slightly, you know, and for whatever reason, we keep on buying it, right? I'm not going to say the word here, but basically, there's a word for software becoming more poor, services becoming poor, but organizations still staying stuck to it and going in that direction. And I think everybody with the PlayStation News and all the various platforms out there, Expedia, and how they've just gotten worse. Um, like it's not going to there's no way to stop the wave. Okay, this is just the direction that things are going, and even if they're bad in the beginning, the general consensus is that they're not. They're gonna we're gonna keep improving and they're gonna get better. All right, so it's we're not gonna go back to the horse. Horses are way better than cars in the sense that they can run for a long time and you don't have to necessarily, you know, buy gas for them. You just let them go graze in some grass somewhere. It's all natural, but cars have their advantages too. And even though there was probably a time when it made more sense to have a horse than a car, and it was laughable to buy a car, right? You know, when you have a horse, uh, eventually that changed. At some point, I think we can all agree that cars became far more valuable to the society than horses because society itself evolves and introduces new problems and new concerns that may not exist in that tier, right? So we as we start to learn about AI, we have to be thinking about the world to come, not the world as it exists today. The world to come is an AI heavy world. And in that AI heavy world, what are the new possibilities? What are the new things that can happen? What are the evolutions that AI can provide that will prevent us from backing down from it? One big thing that AI is doing today is in material sciences. There's all kinds of AI startups out there in material sciences, in medicine, in all kinds of spaces that's been tremendously difficult to do analytics and assessment of because there's just not enough people to do it. But with giant AI arrays and things of that nature, um, these things become easier and better. So so again, we're not going back, right? So let's focus on moving forward and let's look at what we can gain from moving forward. But let's move on to the skills that are becoming valuable, right? So what is becoming valuable, right? So problem framing is extremely valuable now. Judgment and decision making is extremely valuable. Communication is extremely valuable, and I don't just mean being able to talk to the computer and being able to write things properly. I also mean being able to talk to each other and being able to collaborate in a working environment. So, as people in the tech world, we've kind of all grown up. I mean, I know everybody must have met these poor character people that that exist in technology. There's even skits about SNL skits about the IT guy. But those kinds of skills are falling away. Those kinds of patterns of behavior pretty much existed because nobody could do the job. But, now pretty much everybody can do the job, right? That's the whole point. Really, everybody for the most part can do the job with a little bit of training. They have the capability of doing the job. The question becomes, do they have the talent for that kind of problem framing, judgment, decision making? Do they have domain expertise? Do they understand the the space? Do you understand banking, insurance, car rental services? Are you a good business person? Those skills are more valuable. And then system orchestration. Do you know how to if you were asked to put together a payment processing platform that can be generically used by any organization? Could you do that? Could you design it out? Could you think of all the things that it needs to do? Do you yeah, could you work with make it compliant and all those kinds of things, that are required? Those skill sets, those are still valuable for now. I'm not saying that they're going to continue to be valuable, but for now, they are still valuable. And now on the flip side of it, what are the skills that are decreasing in value, right? So the number one skill that's decreasing in value is memorization. Okay. And you obviously, would know why that is, right? Another skill that's all but disappeared is manual formatting. I mean, I can honestly say I don't know anybody that's manually formatting anything right now. And if they are, then my first question is why? And you have to remember that as we move into this new world, um, you don't want to exhibit what I like to call dinosaur thinking, right? Because it's just not gonna work. It's not gonna help you at all to do dinosaur thinking and to try to solve problems the old way. You gotta be thinking about solving problems the new way. And this is the same in all environments. Like when I was coming up in technology, Y2K was a big thing, and solving those problems were a big thing. So I was coming into a world out of college where everyone was doing object-oriented programming, Java, C++, Visual Basic, and then you would go into these organizations, and there would be a problem that needs to be solved, and you have some guy that's talking about oh, I wrote a COBOL file, to try to handle this, and yeah, it does, and yeah, it works great, but no, we're not gonna use it. We don't want to use it. Okay, we're moving forward, right? So your line of thinking, the things you do have to appeal to the next generation that's coming up. And you have to be aligned with what's happening. You can't because nobody wants to move backwards, and nobody wants to be held back by again dinosaur thinking, right? We gotta move forward, right? Then routine analysis. So routine analysis, deep analysis, I think, is still requires some measure of. It's gonna be there, but routine analysis, basic stuff like spreadsheets and hey, summaries and all that kind of stuff. You can all do that with Copilot today. Repetitive documentation, you could do with a combination of code gen and AI today. Once again, so not very useful skills to sell because they've been vastly commoditized, and really anybody, within this a space can do these things. And this is not saying that these skills are going away; they're just decreasing in value. And what do we mean when we say decrease in value? It means that um, it's when it becomes easy for everyone to do it, right? Then its value gets lowered. It becomes something that can be incorporated into a person's regular workflow. It doesn't require a dedicated skill to do, right? And the best way I can describe it is if you can imagine like anybody in the world can think up a tune, right? You can think up some tune in your head, and you can probably whistle that tune. Whatever that tune is, you can whistle it. But you don't have these kind of technical skills, these motor skills, or maybe you do, maybe you don't. A lot of people don't have these motor skills to be able to turn that tune into a song, a pop song, or on a piano and make it sound amazing, right? You have it in your head, you know what you want to do, but there's a gap between what you've actually created and being able to manifest that creation, right? So that same gap has existed for everybody with technology. Over the past 20 years or 18 years, let's just say maybe 16 years, I can't tell you how many people have come to me with ideas for apps or websites or technologies. They have the idea, they know what they want, they have it, but they don't have the wherewithal to manifest it into um, reality. And so they need a person like me or technologists out there, coders, to make it something real, right? Now, with AI, you don't need that person like me anymore. And even on the musical side with AI, there's people that are whistling songs and turn it into fully developed songs, right? Uh, so so this is so this idea of routine and repetitive documentation, memorization, all this kind of stuff, they all manual formatting. I would put the ability to play an instrument as an example of manual formatting, knowing how to put things together, right? Not necessary anymore. Kind of fading away in value, becoming easier for anyone to do. So not something that you would directly hire someone to do, right? It's just not. So then let's talk a little bit about the new role, right? So let's focus on the positive. So what are the new roles and what is the new kind of role that I want to highlight today? And that is this idea of an AI supervisor or a workflow architect, right? So what you're doing here is you're designing how gets how work gets done. You're evaluating the results, you're guiding intelligent systems, and you're integrating outputs into future work that's being done later on. So, this ability to do that and to hold that vision in your head of what you want and be able to manifest it, create it, be able to put it together is critical. And I also want you to think about the idea that so back in the day, we used to build applications. So it was all about can you build this application to do this thing? Word was an application, right? Excel was an application. These are programs, standalone programs that ran by themselves. If you look at how Microsoft Word was in, let's say, 2003, 2004, and you compare it to what how it is now, it's a completely different thing. Word and Excel are systems now, right? They're no longer applications. They're services that exist in the ether. You can open a Word document from anywhere in the world. You can collaborate with multiple people together. Your information that's in that Word document can be surfaced as an answer to a question with somebody else in your enterprise somewhere else. It's this large scale distributed system solution. That's what Word is today, right? It's a combination. The word processing part of it is the probably the smallest part of what makes Microsoft Word Microsoft Word. Literally, it's probably the smallest part of it. There's all kinds of other stuff going on in Word that's far more sophisticated than that and far more robust and require far more concerns than that word processing piece. So what happened? Well, the technology scaled to become part of an ecosystem of technologies, each of them individually its own application, its own technology, its own unique thing, and they are all working together in concert to create this Microsoft Word experience, right? Or what do they call it now? Microsoft Copilot, whatever the name of the whole thing is, right? They they're all working together to create this ecosystem of behavior, right? Or ecosystem of capability, I should say. Why is that? Well, because of the advent of better technologies, network, new approaches, new design styles, new thinking that was able to be created. Well, I want you to push your look upwards and elevate yourself to the next substrate, the next layer above all the technology we have today and keep on rising and keep on rising and keep on rising until the technologies that we have today you can start to see them the way when you're sitting on a plane you can see all the different kind of cities and the rivers it's all coming together and then from that vantage point ask yourself what kinds of systems can I put together, right? Because those systems that you're going to be putting together are now not going to be combinations of individual applications working together. They're going to be combinations of different solutions, complex solutions working together. It's no longer about how the word processing aspect of Word can work with the distributed messaging aspects of Word. It's now about how the Word ecosystem can function with the XYZ ecosystem, right? or whatever else might be out there, right? How can I build a solution that encompasses vast amounts of information, vast amounts of data, all working together collaboratively in some unique way? And that's the opportunity that AI gives us, right? By allowing us to work faster, by allowing us to integrate quickly, some of the things that would take us a long time to do, this kind of vision that I'm describing to you, you would be sitting there, oh, I got to figure out how to program Word to connect itself to Workday. Oh, I got to figure out how to program Teams so that it can connect to my payment platform that I have, FlexPay or Stripe or something like that. Well, what if you could do that in in 30 seconds or 30 minutes, right? 10 minutes. What if that integration is in 10 minutes and it's fully working? What kind of systems could you build then? Right. That's how to think about it. What kind of systems could you imagine then? What if you didn't even have to think about the technology? If you didn't have to think about the technology, looking at all the technologies that's out there right now, if you didn't have to worry about a developer, if you could just wave your hand and make some vision you have in your head a reality, what kind of solutions would you build? What kind of experiences would you put together, right? And what would they address, right? So that's where that's what this new role is. That's what the workflow architect, the AI supervisor is. Okay. So um, and there is a big. I say this to say that there's a huge opportunity that falls out of this, and that huge opportunity is entrepreneurship, right? So because you have all these things at the tips of your fingers, everything changed, right? AI has dramatically lowered the cost of operating a business. You don't need um, all sorts of people to that. One person can run multiple functions. It is going to be the rise of small teams with high output, and I predict you're going to see the 2 person, 3 person billion-dollar organization, right? And I'm a big Star Trek fan, so you'll hear a lot of references from me, right? So running the starship, one person can run the starship in Star Trek. Even if you don't know, you're not a Star Trek fan, you don't know it. The starship is a gigantic vessel. You just think about a massive ocean liner, not the Titanic, something even bigger than the Titanic, and imagine one person being able to do everything in it, right? Clean it, fuel it, everything. One person being able to run it, right? No one else is needed, right? That's the kind of opportunity that AI provides. And maybe it's being tailored down a little bit based on cost and things like that, but it's still a huge opportunity and still should be seen as such. Okay, so preparing for the future, what are the things that we need to do, right? So pick a business process and study it. This is about understanding business processes. This is about understanding people. Develop data literacy, practice communication, learn how to deal with people and how to talk to people because it's going to be very, very important. When skill starts to fall to the wayside, politics takes up its space. Politics eats up the space, and by politics, I don't mean the president and Republicans, Democrats, also. I mean interpersonal politics. Politics, if you're, they always say, if you're not playing politics, politics is playing you. Whenever two or more people are gathered, you know, God is there, but so is politics. you, you have to be able to communicate with people. People have to like you. You have to be able to get your way and get things done without messing people up. And this politics is just very important. And so practice communications, learn systems thinking. This is a skill. Being able to distill things, put things together, see them the right way, because systems thinking helps you build solutions. And I believe, and this is just my personal conjecture in this space, nobody knows the future, but some studies should be done on this. But I believe that a prompt and a system that is being facilitated, supervised by a person who has very good systems thinking right? Understands how things come together, understands how to put things together, is going to work vastly better, at least in the beginning stages, than a system by someone who doesn't. Now, I think that it's going to hit an asymptote at some point because of the way AI functions, your knowledge is public knowledge, right? So once I build a system that is well defined and does things properly, then the next person can just say something like, "Hey, build me a system that's well defined and does something properly." And it will use the principles that I introduced into the platform to do it. So there is going to be probably some kind of asymptote where it's going to be where that distinction between the two is going to sort of like wane, or the value to that scale, the value associated with that distinction is going to just, just tail close to zero. Never be zero, but just be closer and closer and closer and closer and closer to zero. So that's an important thing. And start working with AI tools regularly. Start working with AI tools regularly, right? Across the board, not just Chat GPT, not just Copilot. Start taking your daily activities, the daily things that you do, and converting them into agents and AI. Start learning this skill because the skill is extremely valuable, right? It really is.